Another way of looking at fermentation again, the only difference is we're finally going to look for alcohol. So we've never done that in any of the labs. We've never looked for alcohol. So the only thing that we have to mention about MRVP is I have your lab manual uses this acronym a lot, and it's a little confusing. So they don't just refer to the acronym here on 5.4, but they also use it in like 5.9 and some of the other labs. You'll see it in the application part. So the acronym, the way it works is each of the capital letters represents a different lab, and we're actually going to do all 4 of them. That little mini I in there actually doesn't mean anything. They just kind of squeeze it in there so that you can pronounce it and say INVIC. So the capital I stands for a lab that we haven't done yet, and we are actually going to set it up this Thursday. It's called the indole test. So we're going to do that one on Thursday. The capital M stands for methyl red, which we're going to collect right now. The capital V stands for Voges Proskauer, so we're also going to collect that one right now. And then the capital C stands for citrate, which we're going to collect after 5.4. So we're actually going to get 3 out of the 4 today. And then the indole, we're going to collect, I guess that would be next week. So, all right, so the only reason why we're mentioning like this little subgrouping of experiments is because when we get to our unknown, which is not too far away, the way this is going to work is everybody is going to set up INVIC during your project. And it's going to help you a lot. So the way it's going to help you is because if you're kind of thinking that you're in the Enterobacteriaceae family, so if it looks like you're kind of going in that direction, then the INVIC is going to allow you to basically like distinguish all the members from each other. Because remember, the family's huge. It's like a really big family. There's like Klebsiella in there, Proteus, we said, Morganella, Escherichia. So there's like a long list of bacteria that are in that family. So INVIC allows you to kind of separate them from each other a little bit. So it's really, really helpful for like narrowing down, if that makes sense. So it's going to be super, super, I would say probably out of all the labs that we've done, INVIC is probably one of the top ones, set of experiments that'll help you, especially if you think you're in the family. So if you're not in the family, it probably won't be as helpful, but if you are in the family, then it's going to be really helpful. So, all right, and then I think we just have one thing left, and then we'll draw this out. So I'm going to skip this. So the only thing that we're going to add is just to kind of remember that we're basically just filing this away as another fermentation lab. That's all it is. And we just kind of have to keep in mind, so I know we've done a lot of fermentation labs, and we kind of just have those generic categories: organic acid, organic alcohol. But just remember that the types of acid can be a little different from organism to organism. The type of alcohol can be a little different from organism to organism. So of course there's like alcohol, the type of alcohol you drink, but then there could be other types of alcohol. Even so with the gas, there's not as much variability, but yeah, technically it could be carbon dioxide gas, it could be hydrogen gas. It just depends on the genetic makeup of the organism. So the end products can kind of vary a little bit. So all we're going to do is kind of exploit that in this lab. So we're going to look for mixed acids, and then we're also going to look for the alcohol. So let's draw this out. So this is lab 5.4. And let's see, when you guys grabbed your media, On the cart, we called it MRVP broth. So just to clarify, so again, the way this works, we said there's this set of experiments called MVIC, right? So the M is representing this over here. You find it in the MR. And then there's a V, circle the V, and the V is representing this other test over here. So in our MVIC, we're actually going to gather two of the results right now out of the 4. So, all right, and MRVP is a pretty important one. So let's see, what's in your broth? It was like a liquid. And what was a little strange is there's no germ tube in there, so we're not going to look for gas. All right, and then as far as what's in there, it's actually pretty simple. Let's see, we have we have the usual, yes, we have peptone. We have a little bit of buffer that we'll mention. And then glucose, and that's it. Just those 3 pieces. So we actually don't really need a whole lot. We kind of mostly just need the sugar. Because again, we keep saying that we're going to just think of this as another fermentation lab, right? So this is going to be our starting material for fermentation. If you think about it, it's maybe a little bit redundant because technically we already did this like a long time ago when you guys had the 10 test tubes and you had like the glucose, the lactose, and the sucrose. So it's a little bit redundant because technically you've already done a glucose fermentation lab, right? So the only part that's kind of new again is the alcohol. So, all right, so we have that. One thing to kind of keep in mind, I think we said it a long time ago, so I'll just put it on the bottom. If you are in that Enterobacteriaceae family, does anybody remember, are they positive or negative for glucose fermentation? If you're in the family, you're positive or negative? Does anybody remember? Yeah, you're all positive. You're all positive. So what I just wanted to kind of, because it was a long time ago when we mentioned that. So if you are in the family, you basically are going into this probably looking like you're like expecting something probably to happen. Because we do know that if you're in the family, you tend to love to ferment glucose. Lactose is a different story though. So the lactose was like the coliform, so that's kind of a different. But glucose is a little bit more universal. So, all right, so let's break down, let's see. So we are gonna break up the experiments as like part 1, part 2. Kind of similar to the nitrate, but it's not gonna be as complicated as the nitrate. So part 1, you guys are gonna do the MR test first. MR stands for methyl red. So that's what the M and the R stand for. We'll mention what the methyl red is about, but basically it's just the chemical that you guys are going to add. The whole point of the MR test is so that you guys can test for mixed acid fermentation. So it's got that acid word in it, so we're just going to look for acid again on the MR test. So to clarify, we are going to start with glucose. Like glucose is our starting material. So that's going to be the sugar that we're going to focus on for this fermentation lab, not lactose or sucrose, just glucose. Now when our organisms ferment it, we have mentioned that, so it's kind of a I have like multiple arrows, multi-step process that we don't memorize in this class, but you probably do in physio. It's called glycolysis. Glycolysis is kind of what like kickstarts fermentation. So it's like that initial step. It's got that word lysis in it though. So basically over those multiple steps, what the bacteria will do is it'll literally break up or split the glucose. And it's literally broken up into two smaller molecules. So over that kind of the multiple steps there, it's technically like 10 steps back to back to back. The glucose gets split up, and then what you end up with, we don't call it glucose, we call it pyruvate. So pyruvate is just like what you end up with. So once the glucose is split into two, you end up with technically two pyruvates, so they're called pyruvate. And then yeah, so depending on what pathway the bacteria wants to take, we've mentioned respiration as one option, fermentation is the other. So for mixed acid fermentation, what'll happen is the bacteria will have to have some enzymes here. And it's not important that we know the names those enzymes are, but those enzymes will metabolize that pyruvate a little bit further, and will basically end up with kind of a grab bag of acids. So some of the acids you'll end up with as your end product. I'm just going to list all of the end products that you get. So fermentation is definitely not as involved. It's kind of a shorter pathway, but the bacteria will make lactic acid. That's one acid. Acetic acid. That's another one. Formic acid and succinic acid. So maybe just to kind of make it easier to remember, so lactic acid is something that can be made in our bodies too. Sometimes it builds up in your muscle. Like if you do a really intense workout, your muscle tissue can ferment for short periods of time, and you can actually get lactic acid like buildup. Acetic acid is like basically the stuff you find in vinegar. So that's pretty acidic. Formic acid is something that you actually find in, what is it? Oh, it's in ant venom. So that was like the one thing that I saw. Succinic acid, I don't have an example for that one yet. But basically we have like this mix. We have a mixture of acids. So that's why on the board, your lab manual calls this mixed acid fermentation, because your end product is like a mixture of different acids. So this part is actually going to be pretty easy, because all you guys are going to do is you're just going to add a pH indicator. So you're going to drop in a pH indicator to kind of tell us if you have those mixed acids in there. So it's going to be pretty straightforward. The chemical that you guys are going to add, it's called methyl red. So that's a little confusing because they have the name of the test after the chemical that you added. But methyl red is going to be your pH indicator. We're going to drop some of that in there. And the way that the methyl red works is that if your pH is very acidic, you'll get, it kind of looks like a pretty bright red. So, and that's basically what we're going to look for. So if you do have the mixed acids in there, it should be pretty acidic. It should be so acidic, all of these end products here, like even though we have a buffer in there. So buffers are something that we add to, what they do is they like stabilize the pH so it doesn't move around a lot. But what happens is if you get the mixed acids, it'll be so acidic. It'll be so acidic that it'll actually overpower the buffer. So even though we got the buffer in there, it's going to be so acidic that hopefully you get the bright red. To clarify, because I do think it's a little confusing, your lab manual mentions something about orange and also yellow. Like if you add the methyl red in there, and if you get like an orangey or a yellow color, and they're like, it's a little confusing the way they describe it, but we're basically going to think of that as a negative result. The orange and the yellow is basically telling you that your pH is either like mildly acidic or neutral. So we're just going to kind of file it away as negative. So basically, we're going to look for the bright red. Bright red is positive. So there's no like flip-flop of colors or anything like that. It's just red is positive, and then that's it. Do you guys have any questions about the mixed acid part, though? So that part will be, yeah.
So when you break down glucose, you would end up with all the possible acids, but
all the possible. Yeah.
We're only looking for.
Like one in particular, maybe?
Yeah.
Yeah, it'll be all of them.
All of them.
Mm-hmm.
Okay.
Yeah.
And then our buffer is meant to stabilize the pH?
Yeah, the buffer is in there in case, because your organism might use the glucose for like the other pathway, like respiration. So we don't want the pH to move around for that. So we only want to, but the end products that we're going to look for here, they're going to be so acidic that like the buffer won't matter. So you'll be able to see this come through with the red. But if your organism does like another pathway of the glucose, we won't get red. So it's so we don't get any false positives there. So all right. So yeah. So we have the methyl red. The second lab that you guys are going to do is going to be the BP. And I guess what maybe makes this lab a little different from last week is the BP. You're going to do this in a separate. You're going to do it in a separate tube. So remember that nitrate that we did last week? We did the A and the B, and then we added the zinc, like all together. Here we're going to do the BP in like a separate test tube, if that makes sense. So BP stands for Bogues Cross Gower. It's kind of a random name. Again, it probably had something to do with the person who discovered it. But the chemicals also are kind of attached. We call the chemicals BP. So, all right. And then the big difference is in the BP test tube, you guys are not going to look for mixed acids. You're going to look for what we call alcohol, or 2,3-butanediol fermentation. Butanediol is the alcohol. That's like the name of the alcohol. So it's like really specific. So this is like the specific name of the alcohol that we're going to look for in the separate test tube. So that's really maybe the only new part to this is looking for the alcohol. And I guess just to clarify, so the BP, I know we're going to do it in a separate tube, yes. But our starting material for even the second test is the same. Like we still start here, glucose. So I know we're going to have it broken up into a separate test tube, but glucose, like our starting sugar, is going to be the exact same. And then actually, the beginning part of this fermentation pathway over here, the alcohol, is going to be the same. So this picture over here also applies to this pathway. The only thing we're going to do is we're going to add like 2 more steps. But yeah, so it starts the exact same way. So glucose, glycolysis, pyruvate, generating the mixed acids. So that part is common to both, if that makes sense. So to both the test number 1 and test number 2. The only difference is for the alcohol part, the bacteria would have to have additional enzymes. And again, it's not important that we know all the names, but they would have to come equipped with additional enzymes to basically metabolize those mixed acids. And so our pathway would basically like continue on. We would get something called acetoin, and then finally alcohol, and that's it. 2,3-butadiol. So for test number 2 is just the only difference is we're starting all the way at the beginning and we're arriving all the way to alcohol over here. So we have just a couple extra steps. So then the only difference is now the alcohol is definitely not acidic. So we can't rely on the same methyl red chemical, if that makes sense. The methyl red is not going to help us out with the alcohol, so we have to use different chemicals. So the different chemicals, you guys are going to sprinkle in an A again, and a B, just like last time. The A is a chemical called naphthol, and I think this is the only confusing part. The confusing part is when we add the chemicals in there, they technically don't bind to like the alcohol itself. They actually label like the little intermediate molecule here, acetoin. So I think that's kind of the only confusing part. So it must be that like we don't have chemicals available to label butadiol. So the best we can do is we can throw in some chemicals to kind of label that molecule made right before the alcohol. So we're going to add that in. Then we're going to add in a B. And the B is going to kind of do the same thing as last week. This is potassium hydroxide. B is going to catalyze some color for you. Going to give you some color. So all of these together, the acetoin, the A and the B, we're going to kind of mix them together. And then hopefully we see some color. So, but at least we don't have any like reversal of colors or anything like last week. So if you add in the A and the B again, if you see the red, you can say, yes, I'm positive for 2,3-butadiol. So technically you can say either way. You could say you're positive for alcohol, or you could say I'm positive for acetoin. Either way, you'd be correct. But yeah, so red is positive over there, red is positive over here. And then if you get like a really dark, it's kind of like a rusty brown, that is negative result for the alcohol. So we're gonna look for red in both test number 1 and test number 2. We're looking for the red. So do you guys have any questions though, before I tell you how to head on? Yeah.
Just to clarify, the first, these are both options for bacteria, and they're both going to result in possibly, sorry. So we're not looking for 2,3-butanol in the first side, right?
Oh yes, good question. Correct.
We're just looking for the acid, but
Yeah.
we're considering the acid or the 2,3-butanol as positive results?
Oh, okay. Yes, yeah.
Okay.
One, the acid is one result, and then the alcohol is the other result.
Because that's
Yeah.
what tells us that it's going to appreciate?
It kind of, well, You'll have like other things to help you out too, like if you know it's gram-negative and the shade and all these other things. But it's kind of like an additional tool that'll help you like narrow down for sure.
Is there any
Yeah.
way that we would get like a negative result in one and a positive result in the other?
Oh yes, definitely.
Okay.
Yes, yes. So actually related to Hannah's question, so I'm gonna ask you guys, she's kind of getting there with the questions. I'm gonna ask you guys a question and then give you a minute to talk it over with each other, and then I'll ask on somebody for an answer. So when you guys do this on the project, typically when people set it up, they will get a positive for the methyl red or a positive for the alcohol test, but they generally don't get a double positive. They don't get a positive for the acid and the alcohol. It's like one or the other, not both at the same time. So my question to you guys is why? Like why is it or, and why is it not together at the same time? So I'll give you a quick minute to like talk it over, and then I'll ask somebody for an educated guess, like why it's not double usually. One or the other.
Because if it uses it here on this one, then it won't be able to use it on that one.
Yeah.
You're saying yeah, but you don't know what you're saying yeah to. So look, if it uses it on this one, then it won't be able to use it on that one.
Yeah, no, I get that.
Do you?
Yes.
Okay, because we're starting at the same,
Yeah.
like, okay.
We're using the glucose for both, and we use the glucose production for both of them.
Yeah.
Yeah.
Where does the pyruvate come
From the glucose.
So glucose is break down into pyruvate?
Yes. The glucose is broken down into 10 steps. 2 molecules of pyruvate, which then enter the mitochondria where it oxidizes through the...
Okay, so if it breaks down
So,
into
yeah.
pyruvate, then the enzymes are, if it's positive, we'll end up with like all those acids.
Yes.
But if we do the other one for alcohol, and we already used the to break down of the glucose,
We'll get
then
potassium
we
hydroxide.
won't be able to get that.
Yeah.
But if it's negative,
We get the citric acid,
we get the
formic
alcohol.
acid. Yes.
What's that, bro? I don't know. By yourself? No, my friend. I went to the. So I was like,
So this is not like the reduction test where like if that one's negative then we do that one, right?
kinda, because we're starting at the same process.
So yeah, so then if it is negative then we add.
It's not if it's negative. We're gonna do it either way.
Oh, either way. So
Yeah.
then, but she mentioned separate. Like, we'll have a separate one for BP. Separate one for that.
But we start at the same place.
Yeah. So then,
Technically, yeah, you're right, because like if it doesn't break down glucose, then you won't get pyruvate, right?
Yeah.
And then that's when you'll be able to do that.
yeah, that's why I was just like, is it like a reduction where like if that's negative then we have to do that one?
Oh no.
I'm sorry if I'm making you.
You can be a server.
I'm focused. I have a food nutrition test I need to take before 4, so I'm reading the charts.
Just please, thank you. 100.
I have a chiropractor looking for my neck because I can't move.
100. 100. I'm good.
I told mom, I told mom, I'm going to escape. She goes, why? I'm going to get more than 100 Yeah, I can't move my neck. So I'm going to chiropractor. I slept. My cat was on my bed, so I had to sleep in a very awkward position.
The air drive, there's microbes in the air.
Yeah.
Who doesn't know what it's talking about?
All right. Okay. I'll take a.
If you get it wrong,
So I'll take an educated guess, right?
you've got me.
So I'll ask Evelyn in the back. So what do you guys come up with?
Well, I'm guessing that the first part.
Yeah.
Well, since when you ferment glucose, you get acid either way, fermented acid.
Uh-huh.
So I'm guessing the other part might end up being negative
bacteria does have to come equipped with those enzymes, yes or no, right? So they have to have that. So a lot of times what happens is they'll make the acid, and then they either yes or no, they have to have those additional enzymes, right? So the other thing too is if we look at it the other way, so let's say your organism does have those enzymes, and they make the acetone, and they convert the acetone into alcohol. Is there going to be like a lot of acid around in your test tube? No, right? How come? Because the acid.
Was changed.
Yeah, it's like all kind of along the same pathway, right? So the bacteria is going to take those acids and kind of metabolize them further into the alcohol. So generally what happens is on the project, generally you're back to what Evelyn was saying, like you'll usually, if they're positive for the acids, they'll kind of just stop there. And that'll kind of be the end of it. Or they will have those extra enzymes, they'll metabolize further and they'll make the alcohol, and they're probably not going to have much acid around because the acids are going to be metabolized into the alcohol. Does that make sense? So, yeah.
So just basically, if there was the presence of those additional enzymes.
Mm-hmm. Yeah. So it's kind of like everything's all interconnected. So, yeah.
So the number
Remember?
2 is also
Ribonucleic
starting point glucose, that way you put that arrow?
Yeah. I do like the long, all the way to the beginning. Yeah, so I mean, it starts the same way, like that first half also applies for test 2. Yeah, yes. Okay, so I'm going to give you our methods. So methods are going to be pretty simple for this one. So let me switch to... So we kind of have similar to last time. Okay, let's see. This is like our day 2 methods. All right, let's see. So per person, you guys will need the following. Let's see. Everybody's going to need just 2 glass pipettes. I will show you how to use them since today's the first time that you guys are using the glass pipettes. And then you'll need 4 clean test tubes, just like how we did last time. And then just like the nitrate test, you'll need your cultures from the incubator. Right, so we have those 3. So that's right. Today's the first day that you guys are using pipettes. Let me grab the... All right. And I think he bought us new pipette pumps, and these ones aren't as frustrating as the other ones. Okay. So I know last time we just did like the plastic ones. So the way this works is there's like a little pump that you guys are going to grab from the drawer back there. The glass pipettes, you kind of have to like snugly, I'll like twist it in a little bit so it's a little bit snug. There we go. And then I'll show you how to use these. So your setup is going to look like this. So you're going to have your 1, 2, 3, 4. The reason why we have 4 is because we are going to do an MRVP and an MRVP. And we have, so remember we have E. coli. We have to do an MRVP for E. coli. We have to do MRVP for E. aerogenus. So the way this is going to work is you're going to grab your cultures. They've been sitting in the incubator for 5 days. 5 days is kind of a good amount of time. So a little abnormal for us to have it for 5 days. The reason why it's so long is because we want to give enough time for the alcohol pathway. So we basically, we let them hang out for a little bit longer, just so that they have time to kind of complete the butadiene steps if they can do it. If you incubate for too short, you may not give them enough time to complete that alcohol step, so that's why I went a little longer. But anyways, you're going to grab your cultures, and you're basically going to pipette. So you're going to pipette your little cultures into your MRVP tubes. The amount that you're going to pipette, though, is only going to be 1 ml instead of 2 ml. So I think last week we did 2, right? Yeah, and then so today we're going to do 1 ml. So it's going to be 1 ml into each of the tubes. Now we only have 2 organisms. So like this one repeats, it's E. coli, E. coli, E. aerogenes, E. aerogenes. So you can totally reuse your pipettes. That's fine. It's the same organism times 2. So totally fine to reuse. So the way these work is once you kind of snugly get them in there, there's like a wheel that you put your thumb on, and you just kind of like slowly wheel it down. And as you wheel down, the fluid kind of like gets sucked up into the pipette. When you have to release it, you just push your thumb down on the top and the liquid comes shooting out that way. So the wheel is kind of what draws up as you thumb it downwards. It'll kind of draw up your liquid. I think what's confusing about the pipette though, I don't know why we have pipettes like this, but the pipettes, like the numbering system, so it goes like this, and then there's like a tip at the end. It basically counts backwards, so the middle it'll say 0.5, and then it'll keep going, and then the top it'll say 0. So when you draw up your fluid, you actually go to the 0. The 0 will actually get you your full 1 ml, if that makes sense. So it kind of counts backwards that way. So you're going to draw your fluid up to the 0, and you're going to squirt it out in each of the clean test tubes. When you wheel down your pipette, you can go pretty slow because the fluid is probably going to shoot up here pretty fast. So you can kind of just slowly do that. We'll have the 4, and then basically the rest is pretty easy. So for your MR tubes, you have 2 of them, right? So 1 for E. coli and 1 for E. aerogenes. Go ahead and add 5 drops of the methyl red chemical, and just gently mix it up. So we have that. So that'll be pretty simple. So you just drop in your pH indicator. Your VP tubes though, VP tubes, we have the 2 chemicals. So the way that's gonna work is go ahead, we're gonna add 12 drops of that A, the naphthol, and then just gently mix it up. And then when you're done with that, we're going to do 4 drops of the B, and gently mix up. So for whatever reason, I've kind of figured out that this VP with the chemicals is pretty sensitive, so you do need to do a gentle mix because apparently the reaction needs oxygen. So you do need to kind of just gently shake it up a bit. But what I've kind of noticed over the semesters is that you also don't want to do like a violent shake, if that makes sense. So you don't want to, so don't mix up like, I guess, aggressively, because for whatever reason, sometimes what happens is then the chemicals kind of go crazy and they start reacting with each other, and then it kind of turns like this murky color, and it's really hard to see the red. So it's just do like a gentle mix, And then the other thing too is when you're done doing the gentle mix, just let them sit, like don't touch them anymore. Just let them hang out. They kind of have to hang out for maybe like 15 minutes, 10 minutes, 15 minutes. It does take a little bit of time for A and B to kind of do their labeling with the acetone, so it's not going to be instant. The MR test, that'll be instant, but the BP kind of takes a little bit of time. Something to keep in mind, so on your unknown project, when you guys do this, you will have to be a little patient with that one. Like, so if you are thinking like, I'm expecting a positive result, sometimes it does take like 20 minutes, 30 minutes for the color to kind of seep in, so just keep that in mind. So you guys can grab your gloves.